Yes, hello from FORCE. Welcome for our fifth lesson under rates of reactions. And today we are going to continue to investigate the effect of change in concentration on rates of reactions. So our objective is to investigate the effect of concentration on the reaction rates. Now, last time we did an experiment and we came up with a table. And in this table we have the beaker. We had beaker A up to E. We had the volume of sodium thiosulfate and the volume of water added and the constant volume of hydrochloric acid added. So the fifth column, we are supposed to get the volume, total final volume of the reaction mixture. Final volume of the reaction mixture. So this table is going to be the basis of our discussion so that you can know how to. Now, let's take for beaker A, the volume of sodium thiosulfate was 10. Then we added water, which is 40, and acid, which is 5. So 10 plus 40 plus 5 is 55. So the total volume was 55. And that is what we have. So we have the total volume. Total volume. Then we have the final concentration. So I will have beaker A, this is the beaker, beaker A, B, C, D, and E. For beaker, so we have all those columns. For beaker B, we have 20 plus 30, that is 50 plus 5, 55. For beaker C, we have 30 plus 20, 55. Sorry, 50 plus 5, 55. For beaker D, we have 40 plus 10, 50 plus 5, 55. For beaker E, we have 50 plus 0, 50 plus 5, 55. So the explanation is we took a beaker and added sodium thiosulfate, then added water, then added HCl. So in every case, the final volume was 55. That is our first conclusion, that the final volume was the same. So this one was HCl, 5, 5, 5, 5, 5. Then here we had water, which was 40, 30, 20, 10, and 5. And then here we had sodium thiosulfate, which was 10, 20, 30, 40, 50. Oh, this one was 10, 0. This one was 0. So all those volumes, all the volumes that we have are constant. Then here we are supposed to get the final concentration in moles per liter, molarity. We are supposed to get the final concentration in moles per liter. So what are we going to do? That is the next task. So we need to know go back to the information that was given. Let's go back to the information that was given up there. And the information that was given is here. We were given sodium thiosulfate. We were given sodium thiosulfate. So the molarity of sodium thiosulfate, it was made by dissolving 50 grams per liter. That was sodium thiosulfate, 50 grams per liter. Now, the HCl was made using 2 molar. That HCl was 2 molar. That is the information that we have. So we move back to our table. That is our table. We are even told here that the volume of 2 molar hydrochloric acid. So what do we need? We need the final concentration in this part. Let me create some space here for my calculation. So, what is the original volume? We are going to use M1, V1 is equal to M2, V2. Or sometimes you call it what? C1, V1 is equal to C2, V2. We have the original concentration times original volume will give you final concentration times final volume. Do we have the original concentration of sodium thiosulfate? Because what we need is the final concentration of sodium thiosulfate. Yes, the volume of thiosulfate, original volume is here. That is V1. The final volume is here. This one is V2. So V1, V2. Original volume was 10. Then we added water. We added an acid, bringing the final volume to 55. So, what about the concentration? Molarity. Molarity we'll get from grams per liter. So we must have the molarity. We must have the molarity of sodium thiosulfate. So the molarity of sodium thiosulfate will be grams per liter over RFM. Grams per liter over RFM. What is the RFM of sodium thiosulfate? What is the RFM of sodium thiosulfate? The RFM of sodium thiosulfate, sodium is 23 times 2, sulfur is 32 times 2, oxygen is 16 times 3. What do we get? So this one is 46 plus 64 plus 48. Yes, very fast. 46 plus 64 plus 48. This one will give you 158. It will give us 158. So that is the RFM. So after getting the RFM, we can now calculate the molarity. Molarity of sodium thiosulfate will be grams per liter over RFM, which will be equal to grams per liter. It was made by dissolving 50 grams per liter. So we have 50 grams per liter over 158, which is the RFM. So 50 divided by 158, we get 0.316. This one will give us 0.316 molar as the concentration of sodium thiosulfate. That is the concentration of sodium thiosulfate. So the original concentration is 0.316. The final concentration, we don't know. Original volume is 10 centimeters cubic. The final volume is 55. So we have agreed that C1 V1 is equal to C2 V2. C1 is 0.316 times V1 is 10 is equal to C2, which we don't know. C2 times what? Times V2, which is 55. So this one, 0.316 times 10 divided by 55 over C2. C2 is equal to, so the final volume, which is C2, will be 0.316 times 10 divided by 55. 0.0575 0.0575 molar. Yes, let us meet in the second segment.